What you hear is not just sound. It's a hidden dance of waves, motion, and energy. Physics in action, everywhere around us. In the next few minutes, we'll dive into the unseen forces shaping the way we live, communicate, and feel. Welcome to the hidden physics of sound. Sound begins with vibration. A plucked guitar string, the human voice, a drum beat. Each generates a disturbance in the air. That disturbance propagates as a wave, carrying energy through a medium. But what does it mean to carry energy? And how does something we cannot see affect our world so profoundly? Let's start with the simplest example. Drop a pebble in water. Ripples radiate outward. Sound does something similar, though far more complex, happening in air, solids, even vacuum in very limited cases. There are two fundamental types of sound waves: longitudinal waves and transverse waves. In air, sound travels as a longitudinal wave. The molecules push and pull in the same direction the wave moves. In solids and some materials, transverse components appear too. These characteristics determine speed, direction, reflection, and absorption. In a room, sound bounces off walls, scatters in corners, is absorbed by curtains. Every surface affects it. That's why acoustics matter. Speed matters. In air at room temperature, sound travels about 343 meters per second. In water, it's approximately 1,480 meters per second. In steel, approximately 6,100 meters per second. Why such huge differences? Because molecular interactions change. In denser mediums, molecules transfer energy faster. But why does this matter for our everyday life? Because when we design concert halls, headphones, or even our speech systems, we rely on that physical knowing. And when we don't, we suffer. Distortion, echo, poor intelligibility. But sound is more than waves traveling. It's information. Every word you speak carries patterns of frequency, amplitude, and time. The brain decodes those patterns, letting you understand language, enjoy music, or even hear danger. Visualize sound as a fingerprint. The unique shape of its waveform defines what you hear. That's why a violin sounds different than a trumpet, even if playing the same note.
Now, let's zoom in on resonance and harmonics, essential concepts in sound physics, yet surprisingly invisible. A tuning fork vibrates at a base frequency, but the surrounding air and structure resonate at multiples, harmonics, creating the rich timbre you recognize. This is how architectural resonances can cause undesirable booms, how speakers hum, and how skilled instrument makers craft exquisite sound. Amplitude is volume. Frequency is pitch, but there's phase, delay, Doppler shift, and interference patterns too. Two waves meeting can amplify or cancel each other out. That's how noise-canceling headphones work, by generating an inverse wave, Doppler effect,
A passing ambulance siren sounds higher pitched as it approaches, lower as it moves away. This is the interplay of motion and sound, relativity and miniature. We live immersed in a cacophony of sound waves, from traffic, wind, machinery, music, and our own thoughts. Yet some of the most profound uses of sound are invisible. Sonar, medical ultrasound, seismic acoustic research. Sound waves map the ocean floor, image inside our bodies, detect threats. Vibrations shape our world. And then there's the emotional power of sound. Music uses frequencies, rhythms, and harmonics to evoke feeling. Joy, sadness, tension. Why? Because our brain responds to patterns. Repetition, variation, timbre, all trigger chemical responses. Sound becomes architecture of emotion. In essence, we're built to feel vibrations. So what can we do with this knowledge? We can design better spaces, create healthier environments, craft immersive experiences. We can heal, communicate, inspire, and we can listen, really listen, to the waveforms of life around us. Next time you hear a whisper in the wind, a pulse in the earth, or a melody in your mind, remember, you are hearing physics. You are part of the dance. The vibrations never stop. The waves never end. Every sound you hear is the universe in motion. Thank you for exploring the hidden physics of sound with us. Subscribe, like, and dive deeper into the wave.